Okay, so welcome back to episode 13. So in this episode, as I said in the post update on the community section there yesterday, it's going to be about spark plugs. Now, just one small thing I want to note on the last video in Formula One bearings. I had a slip up of terms, which is important I address it because it was spotted by a few people. Now, I spotted it before I uploaded the video, and I just put in the description, but I don't think everyone reads the description, so I just want to cover it now, just in case people are viewing it and it comes back again. I invertedly said that the tangs on the bearing shells were for anti-rotation. Now, when I said that, I meant that they were, when you're at time of placement, that they don't rotate, that you can only put them in one way, that they're correct. The oil ways into them line up, and they can't move axially. So obviously, as we all know from back in baby school of engine design and assembly, the big end shells are held by the bearing caps from rotating. Now the newer engines do have tangless shells, which I don't really like. I never liked, just because you can be a little bit wrong when you're placing them, and the oil holes don't line up, and you could put them in, spun a few degrees, and the oil holes wouldn't line up. But that's just to address that. One other thing I want to address: a lot of you are saying that the sound, if you're listening on headphones, is mono. Now I'm working on that. I have a mic ordered, so I just want to keep the videos as good a quality as I can. Now, for the time being, as far as I know, there is an output setting on YouTube where you can just turn the sound to mono. Now, I don't know off the top of my head how you do that, but you're smart people, you will figure it out if you're headphone users and it is annoying you. So, spark plugs. We've all seen spark plugs at this point, I would imagine. Now, they're all pretty much the same across all engines. There's a few small differences in the Formula One engine, which we'll touch now, or in high performance engines. Now, in terms of construction, all plugs are made fairly similar. So I have 3 plugs on the bench here. One of them is from a normal road car. I can't remember what car it is. Could be a Golf, could be a BMW, could be literally anything. I've got another larger plug here, which is off an earlier Formula One engine, and I've got a very small plug here, which is off the Cosworth CA V8 engine. So let's do a quick rundown on how a spark plug works, just very briefly. I know you know how it works, but let's run through it anyway. So obviously a spark plug, they've both been cut. These two have been cut just to show the insides. But a spark plug, your voltage runs down the center to the electrode here, which then grounds out on these 2 outside electrodes, which causes the spark. So the spark wants to jump from the central isolated electrode or insulated electrode to the outer, which is the vehicle ground, which is earthed when it is screwed into the cylinder head. So that's fairly straightforward. Again, these haven't changed, back to the days of the Model T. They haven't changed that much. The materials have come on, how they're mounted. Obviously, the tangs here on the top, you can see some of them have just 1, some have 3, some have 4. There's various different designs. Now, a lot of people think that aren't too well up, and that wouldn't be that depthful in knowledge about spark plugs. A lot of people think that these 3 prongs here make 3 sparks and they're higher performance. Now, as you said, this has been cut. There's 1 prong is gone. But the purpose of the 3 prongs isn't actually for 3 sparks, because the spark by nature will jump the smallest gap. The purpose of the 3 prongs is actually just for a longer life. So when one electrode wears down, gets spark eroded away, it'll start jumping to the next one and then on to the next one. So they're just long life plugs, really. And again, you can get them in various high performance materials with palladium, various different things, platinum, various metals, nickel as well, just for long life and a sharper spark. But in terms of the body of the plug, this is generally made in 1 part across all spark plugs. So you see the 1 part there with the threads on it, the prongs as noted. Nothing too special about that. This then is a ceramic insulator on the outside, and you've got your central electrode running down. Now, sometimes there is a small suppressor in here just to stop electromagnetic frequencies radiating from the plug and affecting, you know, the likes of your radio. I'm sure you've often seen years ago, or even now, if you've got a lawnmower, it can sometimes affect the TV or can put a buzz on the radio. That's generally the EMF is coming off the plugs and going out as radio waves. So that's why this is done, um, to suppress that EMF coming out of the plug. Now you've probably also seen sometimes that the bonnet is earthed. Now I remember in one car, not sure again what it was, the bonnet was earthed because they wanted the bonnet to act like a Faraday cage, which will keep all the frequencies under the bonnet. So if you've ever seen a car with a bonnet earthed, that can sometimes be the purpose of it. Again, this is ceramic. These are made of ceramic powder. The ceramic is mixed with a binder. It's put into a mold. It's compressed under huge pressure to get a near net shape, and then it's baked in an oven and kiln at like 2,000 degrees, and it all becomes one part. Then it's pretty much like the powdered metal parts. You've seen them in drills and small gearboxes, where they actually get the metal powder, put in a mold. The gear is made. It's taken out of the mold, and then it's sintered in a kiln. So same thing, powder and a binder, compressed, then it's fired, and that's how the insulator is made. Now, with nearly all, I think, any plugs I've seen, they come with a crush washer here, which obviously seals it to the cylinder head, which seals in the gas, seals out any moisture from the head, and that's what that is for there. So let's zoom in on that, just to give you a close look at the crush washer. Turn the plug the right way. So you can see the washer there, nothing special, it's just a hollow two-piece washer that squeezes down and provides the seal. So that's pretty simple. Now, in terms of plugs, you've all heard a hot, a cold plug. Some of you may know what that means. Oftentimes I've seen the meaning get mixed up just because people look at it the wrong way. So I'm not going into the exact terminology of what you think or what I think a hot or cold plug is. I'm just going to tell you how the plug works, what it looks like inside, and whether or not that means it's hot or cold. So I would be calling this plug in my hand here a pretty hot plug. And the reason for that is, if you look around this insulator here at the end, there's quite a bit of free space around it here and here. Now keep in mind, this gets very hot when it's, you know, this is the combustion chamber here, so it gets really hot. Heat travels up here, travels up the main central electrode, gets into the ceramic, and it can't get out until it's in contact with the main body here. So in a hot plug like this, the reason this plug is called hot is because you have such a gap here. So you can see that gap there and that gap there. Now that gap means that no thermals can flow from here to here. It can't conduct through the air. So it has to go all the way up here in order to conduct into the body of the plug and off into the cylinder head and be taken away with the coolant. So this is a hot plug. Now the reason this is a hot plug is because when you, like, passenger cars, they're stopped and started all the time. They're rarely run at full load constantly. Like lawnmowers are especially a great one. You've often have to clean the plug in the lawnmower several times, especially when you bring out over season. And that is mainly because they're always running rich. They're always cold starting. The air filters mightn't be up to speed. And that has the effect of coating all this electrode here in carbon and general crud. You've all taken out spark plugs, put your wire down here, clean out all that crap. That is why. So all this carbon gets in here, in here, in here. And because that all forms there, the plug can start arcing across the carbon here and not here where you want your spark. So the reason they design plugs to be hot is this tip then has the effect of staying very hot if it can't conduct the heat from here to here. So that is the effect of burning off all this carbon on this part here. So it self-cleans, if you like. Every time it gets up to temperature, it'll burn off the carbon, and that's why you have a hot plug in a lesser performance car. Now if we move on to just one thing first, actually, when a plug has been assembled, while I think of it, this goes in here, obviously, as you know, like so. There is little sealing rings on it. So these rings are just, again, like a crush washer, as you can see. So that one will go in there, like so, and seal against that seat down there. So keep in mind the combustion chamber is under pressure, so it has to be sealed. The gas can't flow out here. So that's the first one. That's the first main fire seal right there, or the first gas seal. Now there's generally two more in passenger car plugs. One would be there, like that. And then what they do is to form just a secondary gas seal. They'll put a powder in here similar to talc. It just gets packed in there over the seal. And then they put on another ring here, like that. So you've got two rings with the talc powder between them. This all then goes into the body of the plug. They get squeezed down like that, and the plug then gets crimped in over it. It gets swaged down to lock in the insulator into the body, and no gas can come out. Now to open the plugs, if you ever need to open a plug, you really need a lathe, or an angle grinder could do it too very carefully. You just turn off that swaged area, and the body will come out. It's just turned in around the body like that. So you have to cut it off, and you can remove the body, the insulator, for whatever reason you'd ever want to do that. I have no idea, unless you're making a video like this. But that's a standard passenger car plug, standard in a lot of semi-high performance cars as well. Now you can go hotter or colder plugs in performance cars, which I won't get into because it's a minefield, and get the plugs that suit your car is all I'd say. So that is a passenger plug. Now onto an earlier Formula 1 plug, just to show you the difference. Now first of all, you'll notice size wise straight away. Now remember the casting video of the new technology that they developed for the smaller passageway in here in the head with the ceramic insert in the sand core. So everything is related to each other in a cylinder head inside. So the smaller you can make a plug, the smaller you can make that area, the more coolant you can get around that area. So it all has a knock-on effect on each other. So in terms of length, they're various, they're various lengths, but these are almost the same. But the big one in this is the diameter. And the other thing with these plugs is their surface fire or surface discharge. So there's no tang. Now, the reason there is no tang in a Formula 1 engine is it's got two reasons really. Number one, the tangs are huge. So these tangs stick down about 6 millimeters. So as you can imagine, in the Formula 1 engine, there is no room for that in the combustion chamber. It has to be pretty flat. The squish zones are very tight in the chamber, so the pistons would hit this if it were that long inside the combustion chamber of a Formula 1 engine. So the second reason is, apart from the length, is when these tangs, and just zoom in there, you can hopefully see, yeah, you can imagine these sticking down in the combustion chamber, they get very hot. So because they're so far away from the zone which takes the heat out of it, which is here into the cylinder head, they can get very hot, and you run the risk of those tangs glowing and lighting the mixture before your spark lights it, leading to all sorts of bad things happening, detonation, preignition, all them sort of things. So they're the two main reasons. Now, getting back to the earlier Formula 1 plug, let's have a look at it. So you can see here the tangs are gone. Now these normally mount into the cylinder head completely flush. So there's nothing sticking down the cylinder head at all. You can have a very tight combustion chamber roof, and you don't run the risk of any parts glowing. Now, in terms of hot and cold plugs again, remember this is hot because it has no material here to suck the heat away from this. Now Formula 1 plugs run a lot cooler because they need to, because they get quite hot. You can see the confusion coming in here, so I won't go into it too much. But these plugs run a lot cooler here. The electrode is right beside the metal. The heat can go right into the head from here and from here, and it doesn't have to travel all the way up here to get a conduction path, a thermal path like this one has. So this one runs hot to burn off any crud, cold starts, mixture, oil mist, stuff that makes it in past the filter, rich petrol, etc. has to be able to self-clean itself just with burning it off internally. This one doesn't. Remember, these are high performance plugs, so they're not worried about this getting all black soot like your lawnmower engine or like a really old car. These are changed regularly, so they can run cold. They don't have to self heat or self cleanse via burning, so they can keep the material right here beside the insulator, keep this as cold as possible, suck all the heat out of it, and you've got no carbon build up here. Now, the one thing with a cold plug is if you were to leave these in an engine for, let's say, 50,000 miles, because these never get that hot, they don't have the self-cleaning ability which the normal road car plug has, which I showed you a second ago, because they're running cold always. So they can't self-clean. If these get dirty, they're not going to burn themselves off. They're just going to start arcing and cause you all sorts of issues. Now, with this plug, again, same construction. Just slide that out there. Hopefully it will come out. Yeah, same thing. If we just put them side by side, take off the rings of this one. So pretty similar. This one, obviously, because it's a passenger car and it's got a lot more regulations to follow, I would imagine there's a big suppressor living in here. Now, I'm not sure what's in here. There probably is a small one, but it's not so much of an issue in a Formula One engine because I think the EMF regulations with race cars are a little bit more relaxed. Now, you would still have to make sure your ECU and your various electronic components on the car can accept any of this EMF coming off that plug. So, or else it could drive electronics crazy, which I'll get onto in a moment with the microscope. So not a whole pile of difference. Same thing. Now there is only one gas sealing ring in this plug in the earlier Formula One plug. Mainly because again they don't live that long in the engine. They're changed a lot, so it's lighter. It's easier to make, less parts, and again, so you can see the progression of the plugs getting smaller throughout the years and as you go. So car plug, early Formula One plug. Now let's bring on another plug, which is the latest plug of the Cosworth engine, which is this one here, the CA. Now this plug to me is tiny. It's way smaller than the rest of them. This I think measures approximately 7.5 mil or 8 millimeters. It's about half the length, but again, same design principle. It's got the surface discharge electrode, same as this one here, same technology inside. Runs cold again. Now, again, you can see the progression during the years. The cylinder head guys really forced the spark plug designers to make them as small as possible because, for the reasons mentioned, the combustion chamber cannot have a huge mass here to accept the plug. It's just not acceptable. So this has to be as small as possible. You can get as much coolant around there. The boss is small. There's no hot spot in the chamber where a huge boss would live, and you can get good chamber support on the combustion roof in the galleries, in the coolant galleries. So the only difference in terms of removing these plugs, you've got your normal hex plug spanner for the road car ones, but these ones use a castellated tube spanner, just because this drilling down here is so small. You can't afford to put a big socket on this again, just because it's so tight in terms of space. Keep in mind these are high up in the engine, so you want to keep your center of gravity lower. So everything matters. Even the weight of these matters, and the knock-on effect of having these smaller means the boss they go into is smaller, so less weight, less mass high up in the car. Center of gravity is lowered. All good. So you may or may not have seen a spanner like this. It's basically like what is it like? It's like a rook chess piece, like a little castle. So the tube would have little teeth cut on the end of it, goes down over those, locates into them, and you can remove your plug. Same with the CA V8 plug, same idea. Now, the one thing they did improve with the CA plug or the later plugs is, instead of this crush washer here, which is another part, number one. Number two, it would lead to a stack up issue. I mean, you could go hard on this, there might be a little difference in height, and this would end up, it could be plus or minus 0.3 millimeters, depending on how the crush washer behaves. Also with the crush washer, it's a thermal barrier. Everywhere you have a join, there's a tiny bit of air in the interface, and heat won't travel through there as good. So what they did with the CA plug is they revised the design. They came up with a tapered seat similar to a Dash AN fitting, a male fitting. So you've got a tapered seat here. You can control exactly the tolerance between this seat where it's machined. It's all done in one operation. This seat here and the end of the plug. So that's a fixed datum where that will mate to the cylinder head and onto the end of the plug there in terms of how far in or out it is. You know, it'll be spot on. Added to this, you've got far better conduction from the insulator and from the body of the plug out through this generous surface here, which is a lot of surface area, which can travel into the cylinder head. So that's kind of how they differ. Now the surface fire or surface discharge plugs are not new. I know there's going to be people commenting on the video that, you know, I saw them 40 years ago in a marine engine, a Johnston marine engine. I know, they're not new. They're not new at all. They've been in I think some motorbikes, scooters, high performance stuff, maybe even some chainsaws. I don't know. All I know is what I have on my bench, Formula One engines. That's what I know about. I don't know if they were in boat engines, if they were in tanks, tractors, no idea. But this is what they are: surface discharge plugs, very compact, no electrode hanging out at the top, and that is what Formula One engines use. Now, what I'm going to do is just to show you. I've got a 30,000 volt power supply here, just to show you how the sparks behave on the different plugs. Now I had intended using the microscope, the USB microscope, to show you the shape of the spark and how it forms. But sadly, when I turn on the 30,000 volt transformer, set these up and put the plug sparking, because there's no protection on these plugs, the EMF comes into the microscope and disconnects it from the USB. So it just breaks down communications on the USB communication lines. So I can't use that. So I will have to break the video, set up one plug, record it, take the phone down, record it, break the video, set up the second plug. Let's do all three plugs. So you're not going to notice any difference, but it's a bit more hassle for me, but that's what it's all about. Is there anything else to mention while I'm here? I don't think there is. Now you will know that in the later years, like what I call later years, if I ever mention in videos, you know, recently to me is about 30 years ago or 25 years ago. As you get older, you know, you think a car made in 1990 is still new. It's actually not. It's, you know, it's 33 years old. But in the later cars, they used coil packs directly onto the plugs, which are the pencil coils. Anyone with a BMW or an Audi or whatever else, Mercedes, will be well used to changing these coils, the pencil coils. And the reason is because they're down in the heat here. It's a terrible environment. I mean, they're living in, you know, a 150-degree environment all their lives, and the heat just breaks them down, and that's why they fail. And the same again, like they're both at the rocker cover up here on the top, so the heat just kills them. But getting back to why I started talking about that is a Formula One engine also has coil packs. It's coil on pack, COP. So it's a similar system. The coil goes on here and it's fired directly on the plug. So all the high frequency stuff is done in here, the high voltage stuff is done in here, and the path to ground is as short as possible. Like if you had some of the earlier cars had the coil mounted on the bulkhead with large long wires then coming in here with high frequency coming in along the wire for, you know, half a meter. It's not what you want to do. You want to keep high frequency, high voltage stuff as near to where you need it as possible. So that's why coil on packs exist. They're not fun if you drive a car with them. I think I've replaced probably, I'd say 20 on different BMWs over the years. Now one tip is, if you can do it, to bore some holes in the engine cover, just let out the heat. It gives them an extra few miles, but that's the deal with coil packs. So what I will do now is set up the first plug here on the high voltage supply, bring down the phone and give you a look at how the spark behaves, and I shall talk in a sec. So first of all is the road car, the passenger car spark plug. Now I have the phone brought down, as you can see. Now you can see a good healthy spark there. Again, this is not something you really want to do on a bench. They're high voltages. The power supply is actually 40,000 volts and probably about 20 milliamps, but this will put you back if you touch it. So if you're around ignition systems, just be careful and take precautions. But you can see the spark dancing onto the electrode there. Now it hasn't got onto the other one just because of the nature of the plug, you know, the way it's set up or the way it's lying. So that should give you an idea how that works. So let's swap out into the older type spark plug, turn this off, swap in that one and have a look at the surface discharge to see how that works. And then lastly swap in the Cosworth CA V8 item, the latest more modern plug, and have a look at that. You can see the spark just dance to the left electrode there for a moment. So catch you in one second. So now we have the earlier type Formula 1 plug swapped in onto the high voltage set, and you can see the plug dancing now, this time just across the top of the insulator and grounding out to the cylinder head. So a big difference, you know, a very shallow spark, no electrodes hanging down, and again this is a cold plug. So you can see it dancing around there side to side. Now this does have, because the Formula 1 engines run at a high voltage, the spark when it starts initially has a slight cleaning effect, like an AC TIG welder. When you're welding aluminium and you turn it to AC, just the way it generates the arc across, it has a slight cleaning effect on the electrode, but not as much as the hot plug would, where it physically burns off the carbon and the rest of the residue. So that is that plug dancing around. So now let's swap in the latest one. Have a look at that. So this is the latest and the smallest Formula 1 Cosworth plug. The Cosworth CA engine accepts these plugs. You can see the spark again dancing similar to the last one, and again running around the top of the electrode there and arcing to the side. So surface discharge across the top of the insulator. Again, as it arcs away a small bit of the outside ground, it'll jump to another place. So you know, they're very reliable. Again, they're very close couple, short nose. They're pretty cool. So that should be that. I'll take probably one more video just of the nose of the plug. You can see the arcing marks across the top of the insulator, and I'll give a bit of a talk just on the older type plugs, and that should wrap up this episode 13. So there we are, all plugged out and safe. Again, be very careful. Pay no heed actually to the polarity markings on this. It means nothing. They're just spare parts I had. So if we take up this plug again, you may be able to see the grounding. You may not. You can just see it there. You just see where the high frequency the high voltage just cleans the end of the insulator. Sadly, it won't zoom too well. This is what I wanted the microscope for, but it is what it is. So that kind of covers Formula 1 plugs. An interesting enough topic, you know. Kind of taken for granted, I suppose, but vitally important. You know, if they give trouble or they stop sparking, you know, you're a cylinder down. So in terms of the CA engine, that's an 8th year power gone, and it's not going to be good. One last thing I want to just touch on is, it'll probably be mentioned, which was the old method. I'm sure the older guys remember of all the talk that was done in magazines. I remember the Practical Motors magazines back in the I suppose the early 90s, about clocking spark plugs and how much it was so important to have the electrode in the right spot. Like, you know, ideally, if you wanted, this was your valve here, you know, they used to say to make sure to have the electrode not facing the valve, so that the mixture could make it right in there and the electrode wouldn't shield it. Now, I think there was a lot of studies done with this. It affects the overall output of the engine, I think about 1 horsepower or 2. That's if you can trust your dyno down at those very fine resolutions. But clocking spark plugs, it was a huge thing, to have, where the electrode ends up. Um, Guys used to take off these washers and grind these down here so that it would tighten in a different place. So you'd have it all tight, and you'd put a mark on the plug here where the electrode was, so that you'd know then looking down where it tightened to. But it was just funny reading. Now I'm sure there is people saying, "Oh, I clocked it. I get 20 horsepower more with the plugs clocked." No, you didn't. Um, but that was done a lot of years ago. You'd probably get more performance if you actually waxed the car, because it'd have less drag and you'd probably get more out of it than worrying or indexing your plugs where they finish up. But yeah, that's spark plugs. Just a brief mention, I mean, these are about a third of the weight of a road car plug. I mean, you can see they're tiny, so like half the length of your small finger or 3/4 the length. So hopefully that covers spark plugs. Episode 14 next. I'm not too sure where it's going. I wanted to do one on the coolant lines and the hydraulic lines, brake lines, and all that on cars, on the Formula One cars. But I just want to gather a few parts and do it properly for that yet. So I probably will do it on. I've got a few carbon fiber parts here on the shelf, so I'll take down one of them. Um, just have a look at how a carbon fiber part is made. Just a basic part. Now we'll probably move on to more complex carbon fiber parts down the line, but let's just grow the channel gently and see where it goes. So that's that, folks. I hope you had a great Easter, and I shall talk to you in episode 14. Have a good one.